Now let's talk about descriptive statistics a little bit. We can use R and ggplot2 to present information about univariate data sets, not joint data sets. So we're going to start with all the grades for a midterm and a class. You won't see them all here, and that's not super important. You can always go and copy them from the notebook. What are the results like? Well, you can start by building a histogram of the grades. I mean, if you just look at this, in the script window, you don't even see them all. In the console, they're looking like they're all over the place. Let's try to do a little histogram. By chunks of 10, we see that there's about 5 or 6 grades between 20 and 30, roughly speaking 10 between 10 and 40, about 25 between 40 and 50, and from this point on, all of the grades are passing grades. 35 between 50 and 60, 40 between 60 and 70, 50 between 70 and 80, roughly 40 again between 80 and 90, and about 20 between 90 and 100. Now, this information doesn't really provide us that much in terms of like what the most frequent value is, and this isn't the best looking chart you can imagine. We'll do a little bit more. First, I'm going to define a function here, and this function is going to identify from a list of numbers the mode, the most frequent value. Now, on its own, if I run this, nothing's going to happen, except I will now have created a fun mode function that has been compiled and which is available to me. Now we'll create a nice visualization which is going to contain a lot of the information about data set. So we're going to use the grades. The aesthetic will be the grades. We're going to plot a density plot. We'll have a histogram with bins that break by chunks of 10. We'll fill them in blue. I'm going to add a rug which will show me exactly where the grades are, and then I will vertically add in red the mean value, in dark blue the median value, and in black the mode, the most frequent value for my grades. I have to call the library ggplot2, otherwise this isn't going to make any sense. And this is the plot that I get. My mean value is about, well, it's hard to read here. It looks to be about 70, same as the median. Mode looks to be this thing. Why don't we try to actually numerically compute them? The mode is 66. You can also compute the median, 70, and the mean are 68.73. These values are compatible with the 3 locations of each of these lines. Now, remember, if you haven't defined fun mode, it won't know. I'm going to call that you have to define it and compile it for. There's another way in which you can visualize the grades. If you don't want to use a histogram, you can use a box plot. Sure enough, you're seeing the median value is here. There seems to be a larger spread, skewness towards the lower end of the spectrum, tighter spread for the upper end of the spectrum. You can do a little bit more about this. We can do a little summary to get some of these numerical values. So this is nice because it's going to compute the median and the quartiles for you without you having to compute them explicitly. Now keep in mind, it might not use the same rule to compute the quartiles as the one we've seen in class. There's tons of different rules you can use to compute quartiles. 55, 70, 82.5. We see what the minimum grade and the maximum grades are. That's good. So another question to you is, how is the class doing? Is the class doing well, or is the class not doing well? From a professor's point of view, this is actually a pretty good distribution of grades. From a student perspective, well, if you think you're an A+ student and you got your A+, you're probably happy. But if you think you're an A+ and you got your C+ instead, you're probably not super happy. But this is where you would expect the central tendencies to be. This is also what you would expect the median and the quartiles to be. It's not unusual to see that kind of a distribution.